Okay, recently we went through and we learned all about our little items here called SOHCAHTOA, which is just an acronym way to help us with remembering how to find sine, cosine, and tangent, a mnemonic device. Remember that sine is the opposite side over our hypotenuse. Cosine is our adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. And we went through and we've done some practice with these things now, and we understand how do these things stack together. But we can actually do more with these. We can actually use these to find missing pieces of right triangles, which is very handy whenever we need to take and actually do calculations and find things out in the real world. First step we need to do, though, is we need to make sure we have our calculator set in degree mode. No matter which calculator you use, whether it be one online or a handheld calculator, make sure that it's set for degree mode, because by default most calculators are set for what's called radians, and we are not going to be using radians. We're using degrees for our angle measurements. Okay, to do that, let's see here, I like to use our online calculator of Desmos, so I'm going to click on it and go here and show you how in Desmos I would take and set it to degree mode. Up here in the right hand corner there is graph settings. I'm going to go through and click on it and scroll down to the bottom. Notice it is set by default to radians. I need this to be in degrees, so I'm going to click on degrees. Now my calculator has been set and I can come back to it as need be. So moving along back to our problems, let's look, how do we actually use these then now that my calculator is set correctly? Well, this first one here, I have given this angle here, and it says find the missing side here. Well, this is my opposite side. The opposite side, and I'm given the hypotenuse. The opposite side and the hypotenuse, that would be my sine, because sine is opposite over hypotenuse. So I have both of those pieces. So I'm going to go through and set this up into an equation here. So I'm going to say the sine of 28 degrees is equal to the opposite side, that is my variable, my x, over the hypotenuse, which is 19. Well, my goal is to get the x by itself, so I have to go through and multiply both sides of my equation by 19, the left side by 19, the right side by 19. Well, on the right side, the 19s will divide out, making 1. On the left hand side, I now have 19 times the sine of 28 degrees will tell me what x equals. I need to know, what does x equal? Well, that's when I go back to my calculator. Going back over to my Desmos calculator. It's set in degrees. I'm going to put right here. I'm going to use our on-screen one here and type in 19. Click on the button that says functions, and I'm doing the sine of 28. And it gives me right here 8.91995, a whole bunch of decimals. We don't need all those. Our instructions tell us that we need to round this to the nearest hundredth, so that'll be 2 decimal places, so 8.92. So coming back over here, I would say x is equal to 8 92/100. Once you get it set up in your proportion, or set up with your sine, your cosine, and tangent, you're going to go through and use that to help you find the missing side. And it's just a matter of putting it in the calculator. Now looking over here at this one, in this example, here's my angle. I have the opposite side and my adjacent side. The opposite and the adjacent, that would be the tangent, because the tangent is the opposite over the adjacent. So I'm going to say the tangent of 41 is equal to, my opposite side is x, over 32. I can go through and multiply both sides again by my denominator, my 32, to solve for my x. On the right hand side of the equation, the 32's go or divide out to 1, so I now have 32 tangent 41 is equal to x. So x is equal to, well, go grab my calculator again. And when we plug that into the calculator, (32) functions tangent of 41, we see that it is 27.82. So going back here, 27.82 is our missing side. Continuing along with similar type things here with this next one here. Our angle at the top, this one is 21 degrees. Here I have my adjacent side and my hypotenuse. My adjacent side and my hypotenuse. So if I have my hypotenuse and adjacent side, that would be my cosine, because the cosine is the adjacent over the hypotenuse. So I have the cosine of 21 degrees is equal to the adjacent side, x, over 26. Multiply both sides by the 26 to clear the fraction. 26, 26. So I have now 26 cosine 21 degrees is equal to my variable x, my missing side. And I see that x is equal to, and we go punch it in our calculator, punching that into the Desmos here, we see, clear these out. So I have 26 cosine of 21, and it's 24.27. So my missing side for this triangle is 24.27. Now look at this last one right here we have. Now on this one here, I have my opposite side. Here's the hypotenuse. And the hypotenuse is the piece that's missing. If I have opposite and hypotenuse, that is my sine. Opposite over hypotenuse. So let's plug in the information that we do have. So I know that I need the sine of 33 degrees. And that's going to be equal to 15 over my variable. Here, a couple of different ways we can do these. We're going to continue with the same way we've been doing these. We're going to go ahead and multiply both sides. In this case, we're going to multiply by x. So I now have x's sine of 33 is equal to 15, because on the right hand side the x's will multiply and give us 1, because they're inverses of each other. Here we're going to divide both sides now by the sine of 33. Over on the left hand side, the sine 33's will divide out, making 1, telling me that x is equal to, at this point, I'm going to go and grab my Desmos calculator, and here we're going to type in 15 divided by, and then we're going to go in here to our sine of 33. And we see that it's 27.54. It's like, okay, great. We can go find missing sides of just random triangles. What do we actually do with these things? Well, whenever we're working with these things, we can go through and use it to solve problems like this one right here. Because here's an example of how this might be used. It says a wire is attached from the top of a 30-foot telephone pole to a stake in the ground. If the angle formed by the wire to the pole is 48 degrees, what is the length of the wire? Well, first thing I like to do with these is just draw myself a quick picture. Telephone pole. That's basically just like one of the electrical poles, for students out there who are not familiar with what a telephone pole is. And then it's going to create, the wire is going to come down, creating a right triangle. Now they tell me here that the telephone pole is 30 feet. So I can label that 30 feet. And then it tells me if the angle formed by the wire and the pole is 48 degrees. That's this angle right here, the wire and the pole. That's my 48 degrees. How long is my wire? The wire is our hypotenuse. That's the piece I need. So here I have this piece is my adjacent, and this is my hypotenuse. So adjacent and hypotenuse, that will be the cosine, because the cosine is the adjacent over the hypotenuse. Plug in the information that we have, so I know that the cosine of 48 is equal to 30 over my variable, the length of my wire, x, multiply both sides by x, the right side and the left side. Whatever you do to one side of your equation, you always have to do the same to the other. So I now have x cosine of 48 is equal to 30. Divide both sides now by the cosine of 48. Cosine of 48 here, cosine of 48 here. Cosines of 48 go away, telling me that the length of my wire is, and at this point we have to go get our calculator. I'm getting my calculator here. Well, I'll say I'm going to grab my calculator. He's run away. Run away, calculator. Run away. Well, you punch it in the calculator and you'll get that it is 44 83/100 feet long. Example of how you can actually use these things out in the real world. Here we have some more examples of these. We're going to set them up quickly. So the first one here, we have two variables, z and y. My angle here to find the missing sides. This one would be the opposite side. This one would be the hypotenuse. So I could say the cosine of 15 degrees is equal to 20 over y. And that'll help me find the hypotenuse. I could say the tangent of 15 is equal to the z over 20. At this point, once we get them set up, it's a matter of putting things into the calculator. Our next one we have here, here's my angle. I have the opposite side is missing. This is be my opposite side. This is the hypotenuse. It's a good habit to get into of actually labeling everything to make sure you put stuff in the right spot. I have opposite and hypotenuse. So that would be my sine of 28 is equal to, the opposite side is x over the hypotenuse. And then the last one we'll set up here. Here's my angle. This is the opposite side, the hypotenuse, and the adjacent side. So I'm going to do the adjacent side one first, because that would be the tangent of 31 would be equal to 4 over y. And then to find my hypotenuse, I'm going to use the opposite over hypotenuse, so that would be the sine of 31 is equal to 4 over the x. And at this point we would take and use Desmos or some other type of calculator to actually go through and finish solving and rounding the final answer to 1 decimal place. Using trig functions to actually find missing pieces of right triangles. Something you can use out in the real world. Enjoy.